So now I'm going to show you how to find out if something is rational or irrational. And for any math geniuses out there who are watching this video, I know it is only about 99% accurate and I'm missing a few things, but this is expressly designed for my students. So my definitions of a rational number is any number that terminates, which means it ends, or repeats. An irrational number is any number that goes forever without repeating. So let me first point out what a repeating number is and how it can be symbolized. So down here I have 0.5 repeating, which is that line above it, and basically that means that that 5 is going to continue forever. Okay, so it is repeating forever. In this case, the 16 has a line over it, so 16 will repeat forever. So that is a definition of repeating. So both of these technically are rational because they are repeating. They repeat. All right. Other things that are rational are here. This one terminates. It ends. Okay. 3. -3. 0.5 repeating, as we have said. Any fraction with just about any fraction with regular numbers is repeating. What I mean by regular numbers is numbers that you would use to count. 1, 2, 3, 4, 5. Even negative numbers are fine. And the square root of 9, basically any kind of perfect square that comes out to something like 3, that when we square root it we get an answer of 3, which is terminating. Okay, so anything like that is rational. Irrational are numbers like pi, 3.14159, and a bunch of other numbers that continue forever. Okay, nothing there is repeating, it just keeps happening over, it just keeps going forever. I have had students point out and say, look, there's the 1 has repeated. Well, no, repeating means that it's going to keep happening forever. The 1, as you can see, did not keep happening over and over again. It went 1, 4, then 1, 5, 9. So the 1 didn't keep happening over and over again. So that is going forever without repeating. Okay. Imperfect squares, things like the square root of 5, 2.23606, and these little dots after it means that this is going to continue to happen. It's going to continue to go forever, but as you can see, there's nothing that is actually repeating. So that falls into the irrational category because it goes forever, it's symbolized by these little dots, and it is not repeating. And now this fraction, I said pretty much any fraction is rational, but this has an irrational number in it. So most of these, and for our cases in pre-algebra, anytime you see an imperfect square in a fraction, it is also going to be irrational. So if you want to take a look to the left and try a couple of these problems and just tell whether they're rational or irrational, pause the video, and when you come back, I'll have the answers up for you. So let's take a look at our answers. This first one here, -8/4, is rational because it's just a regular fraction. 2/7, again, a regular fraction. 0.3 repeating, so it repeats, meaning rational. And this one goes forever as indicated by the little dots, and it is not repeating. So it is actually irrational. My mistake, I did that so quick, I made a mistake. So let me fix that. That is irrational. Okay, so because it is going on forever without repeating. So it is going on, no number there is repeating. We recognize a pattern, but it's not repeating. Okay. The square root of 3, we don't know. It's 1 point something with a lot of other numbers behind it. So it is irrational. It is an imperfect square. The square root of 36 is 6, so rational. Regular fractions, rational. Regular fraction, rational. Square root of 2 is 1.41 and a bunch of other numbers that it's not repeating and it's going to go forever, so it's irrational. Pi, as I pointed out earlier, is irrational because it goes forever without repeating. And 4.6 terminates, which means it comes to an end, is also rational.